Good day, everyone, and welcome to today's training session. This is to officially welcome each and every one of you to our training institute, to our live sessions, to our training platform, Vatview Tech. So, just as you all know, what we are here to learn is solar power system installations, and as we have it, this class had started some time ago, I think yesterday, and now we are here for a live session. What are we here to do? This is a basic class on what energy audit. How did we arrive at this? We arrived at this due to the fact that some questions arose at the end of our first session on WhatsApp platform. Some people were asking, some of the participants were asking, how do they know how to size the inverter system? What quantity of loads is suitable to be powered using a specific size of inverter? How many batteries are suitable to power up a facility for a specific number of hours? How many panels are sufficient enough to generate the needed and required amount of energy to power up a facility? But then we keep saying and telling you guys that it is energy audit that you truly need in order for you to be a professional in this field. And being a professional in this field has to do with you being able to design an efficient solar power system. That is what it literally means. So that is what we are here to do this night. We are here to walk you through the process of you being what? Being able to take care of the first things first, because there are conditions, there are constants, there are stated out rules which must be followed in the process of system installations. You must follow due process to design that your system, else there will always be fault, there will always be breakdowns. You would always be going back and forth with the client of that project. So yes, we are here to walk you guys through that process. All right, so let us start again from the beginning. Energy audit. What is energy audit? Energy audit is a study that clearly gives you answers to two things. It helps you to answer two things. One, it helps you to know your energy need, and two, it uses the information of your energy need to size your various solar component. What that simply means is that we are trying to know, before you can be able to say this is the size of solar power system suitable to power up a facility, you would have to firstly know what you are going to be powering up using that solar power system. And how do you know what you're going to be powering up using that solar power system? It is the appliances or loads that we are talking about. How much energy are those appliances or loads going to be consuming when it is installed? That is what we mean by energy need. All right, so energy need in summary simply tells you that you are powering up a specific amount of appliances, which in turn would consume a specific amount of energy from your electrical supply. That's what we mean. So what we mean again is that if your appliances are consuming 4,000 watts, it simply means that we are now going to be designing the various sizes of solar component based on 4,000 watt. We are going to be looking into what size of inverters will be suitable to power up your 4,000 watt of loads. What size of batteries will be able to run your 4,000 watt of loads, depending on what we call a standard parameter, backup time. That is to say, how long do you want your system to run. We would also look into what amount of solar panel, now talking about the size and the required numbers of solar panels suitable to power up your load 4,000 watt, and then store up energy for later use. All right, so I'm going to be sharing my screen right now. For you guys to see these things that I have been talking about. So I am sharing my screen. So right here, I believe you can see my screen. This is live from the what training manual, the PDF document we have been telling you guys about. This is the training manual that we told you guys that is available. So this story for tonight is directly giving you from the what training manual. Just like I have explained, it is said here that energy audit is the determination of the what energy requirement for a facility. That is what I have just what explained, and I also added to it that it also helps you to size your what your various what solar solar component. I used to say your inverter, your battery, your charge controller, and your what your solar panels, not forgetting your cable sizing. Now you also have here energy audit helps prevent oversizing of the system, safeguarding your electrical appliances from damaging from inappropriate power surge, and it generally saves you cost. What this simply means that what whichever route you choose to take whenever you are sizing your system, oversizing or downsizing of your solar power system has an effect on that your system. Therefore, you must do well to make good use of what energy audit when you are sizing your solar power system. Now there are other interesting things we love to show you guys when it comes to energy audit. You have the advantages, and the disadvantages of what energy audit. For those of you who have this material already, you can do well to go through it. You have a basic idea of that, but then there is something more interesting to than that. That is what we call what things to consider during what solar energy audit. Basically, there are 4 things you need to take into consideration when you talk about what solar energy audit. One, the list of electrical appliances to be powered. Just like I have said, I made mention of what energy consumed by the facility, and I said that it is gotten through the list of what you are powering up. So what you are powering up gives you idea of what the energy being consumed by that facility. Two, the power rating of those what appliances is another key factor. Three, the daily running hours of the appliances, and the final but not the least, the total energy consumption of that facility. These 4 parameters are what will help us to actually walk through the process of what energy audit. Don't worry, as we progress, you will definitely get to see how these things play out. All right, probably in the next topic we'll be talking about, you will see all of them, almost all of them, if not all of them. You will see them playing out one by one, and you will get to see the role each of them play. They are very important. You can't do without the other. That is how it is right here, right now. So that is a brief introduction on what energy audit, what you need to consider, the things you need to put in place. Right? Good. So in as much as this course is on what energy audit, this class is also on what system design. We are not also forgetting the very important part of solar power system. What is that part? Safety as it concerns solar system. Safety as it concerns solar power system. That is a very vital part of what solar power system. Many installers, many electricians turned installers tend to do away with this, and on the long run cause issues for themselves, because most of them have gotten some facilities burnt. Some have done some unimaginable jobs. But then, this is a very big issue. It is a very big challenge in this field of what solar system. Without talking about safety, you have not done well as a professional. When we say safety, what are we talking about? We are talking about you being able to safeguard the life of not just your what your solar power system, but also your various what appliances. It also has to do with the same safety you give to your what to your um conventional electricity. There is the grid. That is almost the same what safety you should also give to your what solar power system. What are we talking about here? Earthing is very important. How do you earth your solar power system? Can you earth your inverter? Can you earth your battery? Can you earth your solar panels? If you have the proper idea of how these things are done, congratulations. We are also talking about the what? We are also talking about the what is wrong? I will turn this thing around very soon. Yes, I will turn it around. We are also talking about the fuse, the surge, the breakers, DC/DB, AC/DB, and every other safety tool and gadget that is required to safeguard the life of your what your solar power system. So these are what we are here to present to you. We will give you a total breakdown of how all these things play out, how you can safely manage your solar power system. All right. In here, we don't bug you too much. In here, we don't bug you with unnecessary things. So we go straight to the point and then give you what is expected of us. And in here, there will be time for questions and answers. Once that time comes, what did happen? But no fun, but no fun. Don't go now. Stop this one. Who was playing? Are you supposed to? So once the time for questions and answers comes, all you need to do is what? Unmute yourself, tell us your name and your location, and then you can have your say. I hope we are together. I hope we are communicating. All right. Once that time comes, all you need to do is what? Unmute yourself, tell us your name and your location, and then you can go ahead to have your say, to ask your questions, which will be attended to accordingly. All right. I hope we are all together. Okay. I hope we are all together. So now testing the microphone again. Let's see. I hope you all can hear me clearly. I hope you all are following. I hope you all are following. Let us know you are here. Hello, is anyone here? Can you all hear me? Kindly respond. You are here for a reason. We can't just keep talking and no one is responding. All right, you are following through. Thank you. All right, so we also understand the fact that there might be network connectivity issues. So that is why we have also made preparation for that by recording these live sessions, which will be shared. In as much as might not be everyone who gets it, but those who fulfill all righteousness would definitely get all the training live videos. Okay, I hope we're on the same page as we have announced that. All right, so we are now going to the proper discussion of the day. We are going into the proper discussion of the day. We are going into the proper discussion of the day. We are going into the proper discussion of the day, and that proper discussion of the day is what we call what load analysis. So at this point, you may have to write. So load analysis. When we say load analysis, what do we mean? Load analysis is a process. It's a process of processes or procedure with which helps us to know what our energy needs, which guides us to know our energy need. That is what load analysis is all about. All right. Load analysis gives us account of the various what appliances to be powered up. Load analysis gives us the details of the energy consumed by each of those appliances. It also tells us the running times of those what appliances. So in those things to be considered when you are carrying out what energy audit, it is what it is actually load analysis that does that your system designed for. Now let us take analogy of what we call load analysis. Let's take for instance Mr. Jackson, whom we do not know where he's from. Is our client for tonight class. Let's say Mr. Jackson has invited us for a solar power system project in his facility. Now, getting to Mr. Jackson's facility, there are two basic questions to ask. There is to say, two professional questions to ask, and a third one as a bonus. The first question is for us to ask Mr. Jackson his energy need. Now, if Mr. Jackson is a new person to solar system, he might not understand, and so we would break it down for him. We would then ask him to give us a list of the various appliances he wishes to power up using the solar power system. It's at that point that Mr. Jackson can tell us he wants to power up his freezer, he wants to power up his TV, whatever he needs to power up. We would take notice of it. Then we will ask the second question, asking Mr. Jackson the backup time. Mr. Jackson can decide to tell us how long he wants his system to run. So, because backup time is actually how long Mr. Jackson wants his solar power system to run. That is what the backup time tells you about. The backup time has to do with the energy stored in your battery system. How long the energy stored in your battery system, how long is it going to last? Then we are also going to ask the third question, which we call a bonus question. We are going to ask Mr. Jackson to kindly give us an idea of his what budget. Now this becomes a problem to so many installers, all right, because they shy away from asking that budget question, forgetting the fact that asking that question gives you a total control of that what of that project. It really tells you if your client is ready for that project or not. So we always ask, we always advise, kindly ask. Once you have assessed your client and you see that he is the type that wants to do this, ask him, let him tell you what he wants. By chance it might be that the budget might not be enough for that to carry out that project. All you need to do is what, design a system that can be implemented immediately while you make provision for upgrades. So that is the analogy of what load analysis. Like we said, there will be questions midway. So let us what take the first phase of questions, please. Your name and location, and you can ask that question that is in your mind. Thank you. Kindly unmute yourself and tell us your name and your location. With this silence, we don't believe you guys can hear us. We don't believe you guys are here for this class. Are you guys there? We need to know you are here. We need to know you are following up.
Yes, I'm here. I'm following.
All right. So, thank you. Thank you. So, we can now proceed. We can proceed. It's a good thing you don't have a question to ask. So, moving ahead, moving ahead, I'll be sharing my screen right now. I'll be sharing my screen again right now. Sharing another document. So I'm sharing another document right now. So on my screen, as you can see, this is a typical example of what we call what a load analysis table. This is what we call a load analysis table. Why? Because it gives you, presents you with the data or with all the needed information for you to design a solar power system. So this is the information you need to carry out what an energy audit through the process of what load analysis. All right. So um before you can carry out a load analysis on any facility, no matter the amount of appliances that are there, you need to take into consideration three standard parameters. Take into consideration three standard parameters. The first one is the quantity of appliance. The second one is the power consumed by the appliance, and the third one is the running time of the appliance. If you guys have been following up and you have been paying attention closely, you will see that these are the same things that energy audit told you, that these are the things you need to consider during the process of energy audit: the quantity of appliance, the power consumed by the appliance, and the running time of the appliance. So don't lose focus. The reason why we are doing this is to know the energy consumed by the facility. So quantity of appliance has to do with you having a proper idea of how many of the same appliance your client wants to power up using the what solar power system. Is it one appliance, is it two appliances, is it three appliances, is it four of the same appliances? Power consumed by the appliance has to do with you knowing the rated wattages of the what of the appliance to be what powered up. How do you know the rated wattage? It is gotten from the nameplate of that what appliance. Where is the nameplate? The nameplate is um usually found on the body or packaging, that is the carton of each and every of those what appliances, and that nameplate contains what the name of the maker, the country of make, the voltage, the current, the wattage. You just go there, lift your wattage, and you are good to go. Now we talk about running time. Running time has to do with how long does the client intend to power up these appliances. It is also in hours: 1 hour, 2 hours, 3 hours, 4 hours, 10 hours. One good thing you need to know about running time as a professional is that the higher your running time, the higher your cost of what installation. There are no two ways about it. There is no magic about it. So if you have a high running time, you are going to be having a high cost of installation. So do well to advise your clients accordingly to professionally look into these things before you implement for them. All right. So let's say again our client for tonight, Mr. Jackson, has invited us and he wants to power up what 5 appliances after we have asked him that first question to know his energy need. He has given us 5 appliances he wants to power up: the DVD player, the light bulb, the ceiling fan, the refrigerator, and the blender. These are the 5 basic what appliances he wants to power up using the what solar power system. Now, how then do we run a load analysis on these 5 appliances? We have already known about the 3 standard parameters to use. Then, how do we apply those 3 standard parameters? There's a formula to use anyway. There's a formula to use. All right. There's a formula to use. But before that formula, uh, let us take the uh, information of the various what appliances. It is on my screen. I believe you all can see it. You can as well write. Okay. For the DVD player, the quantity is 3. The power consumed is 100 watts. The running time is 1 hour. For the light bulb, the quantity is 1. The power consumed is 100 watts. The running time is 2 hours. For the ceiling fan, the quantity is 10. The quantity is 10. The power consumed is 10 watts. The running time is 24 hours. For the refrigerator, the quantity is 3. The power consumed is 10 watts. The running time is 4 hours. For the blender, the quantity is 1. The power consumed is 80 watts. The running time is 1 hour. Alright, so that is the information of the what of the various appliances. So what is now the formula to use and apply this uh, information? You say that energy need is given as what quantity multiplied by the power consumed multiplied by the running time. Quantity multiplied by the power consumed multiplied by the running time gives you your what your energy need. All right, give me a minute. Start applying that formula. Once I come, you give me your various answers. Thank you. I'll be back. Okay. Have you all done it? Has anyone done it? Has anyone gotten the answers? Mr. Pella, Mr. Jackson, even our client Mr. Jackson has not said a word to us. Has any one of you done it? Okay, so this is the way to go about it. All right, I've stated out the formula which says that what energy need or energy consumed is given as what quantity multiplied by power consumed multiplied by the running time. That is the formula. Now, how do you apply that formula? You are going to use that formula. You are going to apply that formula on each and every of the what of these what appliances, and then some of the various energy consumptions to give you your total energy consumption, which becomes your what? Your energy need. What that simply means is that what? Get the energy consumed by the DVD player, get the energy consumed by the light bulb, get the energy consumed by the ceiling fan, get the energy consumed by the refrigerator, get the energy consumed by the blender, and then sum it up. That is to say, add everything up, it gives you your total energy consumption. That is the procedure which we are going to be applying right now. So for the DVD player, 3 multiplied by 100 by 1 gives you 300 watt hour. For the light bulb, 1 multiplied by 100 by 2 gives you 200 watt hour. For the ceiling fan, 10 multiplied by 10, oh, 10 multiplied by 10 by okay, hold on, you already have an answer, Mr. Fidel. Okay, hold on. For the ceiling fan, 10 multiplied by 10 by 24 gives you 2400 watt hour. For the refrigerator, 3 multiplied by 10 by 4 gives you 120 watt hour. For the blender, 1 multiplied by 80 by 1 gives you 80 watt hour. So adding everything up, we have arrived at an answer that Mr. Fidel, yes, he's saying that the total energy consumption is 3000, that the total energy consumption is 3100, and that is the answer. Yes, that is the right what? That is the right answer. So it is what? 3000. So it is 3100 100 watt hour. So at this point, this is the stage where you would say that the energy need of this facility is what? 3100. It is 3100. Therefore, you can now say, on assumption, that you would be able to use 3.5 kVA to power up the facility, 4 kVA to power up the facility, 5 kVA to power up that facility. Now, when I say 3.5 kVA, some people might have an issue with that. Why? They might think that you have 3100 watt hour. Why are we using 3.5 kVA? Is 3.5 kVA not small to power up 3100 watt hour? No, 3.5 kVA is a very large system compared to what? To 3100 watt hour. If you understand basic conversions from watt to kVA or watt hour to kVA, you would understand that my statement. All right, so here you have it. We have firstly done what we're supposed to do first, going through the process of what? Load analysis, to know what we are going to be powering up, and after that we have been able to come up with an energy need. Questions, please. Questions, please. Are there any questions before we proceed?
I'm sure with me, sir, it's clear. I'm following you, sir.
Okay, our client, Mr. Jackson, you are following. That's good. Okay. Any other question? Any other question or questions? For those of you who are just coming, we are coming in very late because the class is almost over. However, I will take it again. However, you still have the opportunity of getting this class because it is what pre-recorded. All right, it is pre-recorded. In fact, we are recording it live as we are here right now, and it will be shared to each and every one of you. And I say again, especially to those who fulfill our righteousness. So please, questions please, as we wrap up. Mr. Jackson, Mr. Fidel, Mr. Izu, Mr. Omokafe, Mr. Richard, I hope you all are here and can hear me clearly. Kindly do something to make me know you can hear me and you are with us.
I can hear you. I can hear you. I am following.
All right, thank you. Okay, so
Hear you, sir, loud and clear.
all right, thank you so much. Thank you so much. So moving ahead, we are now going to be talking about, we have already talked about the energy need of the facility, of which we have gotten the information. We are now going to be talking
I
about,
can hear you, but I did not start from the beginning because I got the question.
okay, so sorry about that. The video has been recorded and you will get a copy of it. If you have not gotten the other videos, you will get this
Nice.
one.
Thank you so much. Thank you
All
so much.
right, so this is the point where we will have to be designing the various solar power system, having in mind the energy need of 3100 watt hour. Design the solar inverter, design the solar battery, design the solar charge controller,
Oh, yeah. Oh, yeah.
design the solar panels.
Oh, one
All right,
you.
and at the end of the
Then you
day
go.
we will now
Okay.
be able to
I am a fan.
implement
Okay, thank
this
you.
system. But then
This
let me announce it to you guys that this is where we'll be putting a full stop to the training. Putting a full stop to the training doesn't mean the training is over. No, it doesn't mean that. It's not over yet. It simply means that this is the point where you are mandated to pay those your what? Your enrollment fees. And it also means that it is at this point that only those who pays the enrollment fees would continue with the class. All right. So let us get something straight and clear here. If you are scared that you might miss the classes, you shouldn't be scared. You have nothing to worry about. Like I said, this class is being recorded live as we are here right now. Okay, and as you pay your enrollment fees, we would also send these recorded videos across to you for you to uh, study at your own time. At our institute, we give you that flexibility of studying at your own pace, at your own time, and at your own convenience. We say the training is for 7 days. You can take more than 7 days because we have put into consideration that you might be doing other things. So take for as long as you want. We also have slow learners amongst us. So take your time, but make sure you study. We will find out if you studied or not before issuing you our training certificate. So for the payment, you are paying for the various countries. Nigeria, we are paying 5,000 naira. Ghanaians 250 Ghana cedis. Cameroonians 8,500 sefa. Zambians is 250 Zambian kwacha. Ugandans 45,000 Ugandan shillings. So if you are here, you have not heard your platform or you have not heard the amount or the uh, way to make your payment, please kindly let us know now. Once you make your payment, you are entitled to getting the training certificate one. You are entitled to getting all the training materials, videos, and manuals immediately your payment is received. You are also entitled to mentorship. This has to do with if you have any challenge while you are working on any project at all, get across to us. We'll make sure that project succeeds. You also um, get opportunity of what attending live classes like this. It is a one-time payment. We are not asking for payment for anything again at all right, talk to us now for anything, for payment, question about recurring and every other thing. Kindly talk to us now please. Hello, no one is talking, no one is saying anything. We're about wrapping up. I believe you all can hear me. I believe.
See, it's okay. We'll make an arrangement.
Sir, what did you say?
I said it is okay. I'll make an arrangement to pay.
All right. Okay. All right. Thank you, sir. Okay. So, all right. So, if that is all, this is where we'll be calling it a day for tonight's training session. All right. The class continues tomorrow for those and only those who makes their payment. Do well to make your payment. Do well to send in your proof of payment for confirmation. Have a wonderful night rest, everyone. Bye bye.